A couple of weeks ago I acquired a new kind of CPU to play with. It's an ARM2, first produced in 1987, about a decade later than the 6502. I think it should be a lot of fun wiring this up and seeing what we can do with it. I'm not going to go into the history too deeply here and now, but if you are interested, do let me know. Right now though, I just want to get stuck in and see if we can make this do something. I ordered the CPU from eBay, and while waiting for delivery I did a bit of research in the pinout and how the bus signals work and so on, and I designed this simple breakout board. The power and ground pins are dealt with by the board itself, along with some decoupling capacitors, but all the other pins from the CPU are broken out in logical groups, so I'll have the flexibility to experiment with them on the breadboard as I please. Based on my limited research, I also added pull-up and pull-down resistors to some of the inputs, so that I wouldn't need to connect them if I wasn't using them, things like the reset pin and so on. And I mostly got this right, but since then, while the PCB was in manufacture, I did find that there were definitely a couple of errors in the way I'd done the pull-ups and pull-downs, and we may need to deal with some of those a bit later on. And like the 6502, this CPU uses a two-phase clock, but unlike the 6502, it requires it to be supplied externally. And that means we need to supply opposite square waves on the PH1 and PH2 pins, or phase 1 and phase 2 I think they call them. And they mustn't ever both be high at the same time. So the first thing we're going to need to do is build some kind of circuit to generate that waveform, or those two waveforms. I'm hoping I can get away with just using the inverted and non-inverted outputs from a D flip-flop, which should hopefully be changing simultaneously enough not to cause any problems here. But we'll see about that when we get things going. So this circuit is similar to the kind of clock circuit that Benita made, but it's without any of the single stepping functionality, because I think that wouldn't actually work on this CPU anyway. So up close you can see it operating. There's a standard A-stable 555 timer circuit, and the output of that circuit feeds the clock pin of the D flip-flop. The D flip-flop's data pin here connects back to pin 6, which is the inverted output. So on every pulse from the 555 over here, the flip-flop changes state to the opposite of whatever its existing state was, and that just toggles backwards and forwards then. And the outputs from the D flip-flop go through these resistors and drive the two LEDs, and yeah, you can see those are toggling backwards and forwards nicely there. And we also have a potentiometer connected to the 555 circuit controlling the frequency, so I can turn that up and make it faster, and I can turn it down and make it slower again. And it goes pretty slow. I think eventually it will actually stop, probably because the potentiometer gets to too low a resistance. Anyway, yeah, that's working pretty well. So looking back at the CPU, for a first pass I want to hook up the clock inputs to the circuit I just showed, and the power and ground obviously. And to be able to see that the CPU is doing something, I want to try the standard trick of wiring the low address bus bits up to LEDs. And I won't bother with the high bits of the address bus for now. If all goes well, we should at least see some activity on the low pins. I'm not going to bother hooking up the data bus, at least not unless I have to. I don't know what it's going to do. It might mean the address bus is quite erratic if it's getting random opcodes on the data bus, but we should at least see something happening. Since making the board, I also discovered that I got the meaning of the address latch enable pin backwards, as I mentioned earlier. So the resistor on the board pulls it down to ground when its default state ought to be high. So I'm also going to have to wire that to the breadboard's 5-volt rail. I think I can leave everything else unconnected for now though, so I'll go ahead and do that, and let's see what happens. Okay, so that's all hooked up here now. We have the power and ground connected to the breadboard, and two phases of the clock, here and here, connected to the flip-flop output pins. Also, the address bus over here is connected to an LED bar graph display with a 470 ohm resistor arrayed to ground, and the address latch enable pin is also connected high over here. And what the address latch enable pin does is it tells the CPU that it's okay for it to change the state of the address bus outputs. When it's low, it keeps them at their last value instead, and we don't want that. So I think we can turn it on and see what happens. And yes, I can see some activity. Awesome. I hope that shows up on the camera. It's hard with the LEDs. Let me set up a close-up shot instead to show that better. So yeah, there it is, all working as expected. The clock is ticking, and on each tick the address bus counts up by 4. The bottom bits are always low because the ARM instructions are always word aligned, and presumably it's fetching opcodes at the moment. So we also have this potentiometer, so yeah, let's try some different clock speeds. Let's try it faster first. And yeah, that's going pretty fast. Seems to be working fine, all counting up properly. And that's pretty slow. I think there might be a minimum clock speed, so if you go too slow it might stop working properly. I'm not sure if we can cause that. Oh yeah, there it goes. So you see the address outputs are fading there. Seems to be happening on the right hand phase of the clock only as far as I can see at the moment. I don't know which is which. But yeah, there'll be some dynamic elements inside the processor. A bit like DRAM, which needs to be refreshed periodically, and if the clock isn't ticking fast enough, it will lose its state. But yeah, that's really satisfying to see it working. I wasn't sure what to expect from an eBay sale of something so unusual, but it seems at first glance to be working properly. But yeah, it's going pretty well so far. So that's about it for now. Next time I'll hook more things up, I think. Probably not the rest of the address bus over here because that's kind of boring. But the data bus really ought to have something sensible on it. So maybe I can put something on it that would produce some specific effects on other pins that I could then observe. I'll have to think about what's possible there. Of course, when I'm more confident I understand how the bus works, I can hook it up to some ROM and start feeding it a proper instruction stream and, writing proper programs and things like that. Then, maybe later hook it up to some RAM, maybe a VIA or something like that. Yeah, and see what you can do with it. As always, I'd love to hear if you found this interesting. I don't think I've seen anyone else doing this with an old ARM CPU before, but do let me know if you've done that, or if you've hooked up some other unusual CPU from a bygone era. That'd be really interesting to hear about as well. And I'll see you all next time.